Welcome to Mrs. Mahoney's podcast. This is our second in our Unit 7. We're on the top of page 7 and we're going to start talking about predicting products. When we're predicting products, that means I'm only going to give you half of the equation and I'll give you the reactants, and you're going to have to, from the reactants, figure out what kind of reaction is going on, and from that figure out what the right hand side or the products are going to be like. Couple things to remember as we're doing these. Your diatomics, so 7 diatomics. And I know we've talked about those. So again, the Brinkel-Hofs, the way we've looked at it, you make a 7. However you need to remember it, just remember the diatomics. Now, looking at that, again, it's when they are by themselves. In a compound, you still make the compound however it is. Balance the charges if it's ionic, write the formula using prefixes if it's covalent. So only when it's by itself do these have that extra 2. Also, formula writing. I think we've learned by writing, just doing all of our word equations, you have to write the formula first. Okay, we're going to probably start with what I think is the easiest, and it's a combustion. Keywords, if it says like it's burning in oxygen. But again, it's got to have this hydrocarbon. Just magnesium burning in oxygen, that is not a combustion. Because magnesium is a metal, it's not a hydrocarbon. So everything has to happen. You have to have a hydrocarbon, carbon-hydrogen compound burning in oxygen. Then you always get carbon dioxide and water. Always. Always. No exceptions. Always. So let's just do a couple of these. So if I have methane and I want to say, okay, the combustion of methane, and this is how it could look. This is all I'm going to just start giving you. I'm going to say write the reaction for the combustion of methane. Well, you have to start with the hydrocarbon. You know, because it's a combustion, it has to burn in oxygen, and then you get CO2 and H2O. Again, so what if you wrote water first? I don't care. That's fine. Then you have to balance it. So there's 2, and that gives me 2 times 2, 4 oxygens. I'll squeeze in my 2 there for my oxygens. Okay, propane. Is it going to be hard? No, because I recognize it's combustion. Combustion always has oxygen. And what do I get out? Carbon dioxide and water. Okay, remember to balance these. Carbons first, then hydrogens, then your oxygens. So carbons, I have 3 carbons on the reactants, 3 carbons in a product. Oxygens, 8 on my reactants. 4 times 2 gives me my 8. 3 times 2 is 6, plus 4 is 10. 5 times 2 is how I get my 10. Okay, you have 2 more there, the ethyl alcohol, the octane. Why don't you just go ahead and do those, and I will check those. And the last little thing that we're doing, again, I don't think these are hard. So I don't think you need to watch me do them 2 more times. I think you guys can handle them on yourself. I will be truthful, they're kind of fun to balance, so I've left you the fun ones to balance. Leave you guys a little bit of a challenge. It's going to be a short one. You can handle it. Okay, top of page 8. Synthesis. Really, it's just between those 2 elements, and that's all I'm going to give you. I'm not going to give you some of the weird funky ones. We can do those later. And when I'm saying funky, of just putting like carbon dioxide and water, mixed carbonic acid. There's whole rules of what makes an acid and what makes a base. We're just not going to get into that. So we'll stick with kind of the easier ones. That is 2 elements. So when I make a compound between these 2, because over here magnesium is neutral, oxygen is just neutral. These are just 2 neutral elements. But if they make a compound, we get enough energy. What do we get? Magnesium is a +2, oxygen -2, magnesium oxide. Then you have to balance it. So I have 2 oxygens to balance my oxygens and a 2 for my magnesium. Okay, what we're going to find out, these numbers are really important. Remember when we saw the exploding egg? This is telling me a ratio that when we start getting to our stoichiometry, this is telling me how many moles I need. This is my balanced equation. Okay, so lithium oxide. What do I know? Well, lithium's a +1. Oxygen's a -2, so when it's in a formula, the formula is Li2O. You still have to balance, so I have to balance my oxygens first, then balance. Okay, now notice in your packet it says assume highest oxidations. Well, I know that iron can make a +2 or a +3. I know copper can make a +1 or a +2. With the different metals, I used to make you memorize a lot of the charges. So what's going to happen now, I will tell you either A, its charge to make, or I will somehow give you a reference that you know what is the highest oxidation or what oxidation number should I have. Because looking at iron, you should realize I can't just look at the periodic table and know what its charge is. So somehow, some way, I will tell you that information. So I'm going to assume then it's the Fe +3. So that means that the formula is going to be an iron 3 chloride, meaning I need 3 chlorines to balance it out. Then to balance it, the 2 on the irons, 3 times 2 is 2 times 3, my 6 chlorines. Okay, I know at the packet it says metals and an element. Typically you're going to see mostly the ionics, probably the two most common that you will see as far as nonmetals. Hydrogen plus oxygen, I pretty much assume you know that's going to make a water. That's a really weird H, but we know it's water. Another one I'd probably add, another very common one, I've said before, one of my favorite reactions, nitrogen plus the hydrogen, and I get ammonia. This is another equation that I really like. Pretty much these are the two most common covalents that, as far as me assuming you predict the products. You can see a whole bunch of other ones and recognize what type, but as far as you to expect you to know what you're going to get out of it. Okay, the last one we're going to look at today, because we're going to look at single replacement and double replacements. To me, there's a little bit more involved when predicting products. That's why we're going to spend a little bit more time on it. Decomposition, I'm just going to do a handful of these. What can you do? Break it apart. Okay, this is where you definitely need to keep in mind your diatomics, because what is the only thing this is going to break into? Magnesium and oxygen. Again, go back, don't forget to balance. What's the only thing this can break into? Hydrogen and chlorine. So I think you guys can handle the rest of these on your own. And again, you can see we'll see other types of decompositions. But as far as what you're going to see that I will give you on a quiz or something to know what to expect to break down, we're not spending the time to go into the rules of what an acid breaks down or what a base breaks into and the different rules, the different ones. So that means we're just going to keep it simple at this point, and we'll spend, if we're going to go on and take Chem 2, AP Chem, that's what we'll spend a little bit more time of how we can know some more of the reactions. So you have a few more I want you to finish. Told you it wasn't going to be very long. And I will see you tomorrow in class.